welcome to episode 13. There's a lot to cover in this. It's going to be like an hour of stuff. We've got controller mounting, the inverter, the contactor box that's going to go under the dash. We finally found a place for it. We're going to build our circuits, the 12-volt battery box, the 12-volt EV circuits, the high voltage cables, the heat shrinking, the cutting, the routing with the conduit. And then we're going to visit EV West and do a roll call of all of our parts so as we move forward into getting all these connecting bits integrated. Thanks for being here. Time for the fun stuff.
About 1 inch size, and it looks like it's bigger than the EV West size, but it's supposed to shrink 3 times, so let's try. And you see there's a little bit of glue all the way around the perimeter, but now we have 2 colors to work with. If we more or less line up the top holes here on the top right in this guy, then they sit about the same plane once we elevate this. So I'm going to figure out how to modify this bracket or what sort of mounting to use for it. Emails. Let me tell you, the dollar store metallic markers, I love these things so much. I'm buying all of them all the time. Today on the 164 EV build, it's time to do a roll call. Who's left and where's it going? If you can make sense of Santa's workshop here, I have everything laid out. We have all of our components. We have our brain box. This is the master of the entire thing, the controller. It's got the chill plate underneath. That chill plate is ready to get plumbed. There are connectors at the top here. These are M8, the kit that EV West sold me, which is like a universal style kit, but with the 7 modules as we're using here. That is including 10 M8 connectors and 10 M10. These are all for the 2-watt wire, the heavy duty orange cabling. That failure right there. So as we get set up, this is stuff that's going under the hood. I need to figure all of this out so that I can pull out the HVAC system and get some hoses made for the air conditioning. Because they only gave me 10 of these, I had to do a final count, and it looks like we're gonna need upwards of 18 of my M10 boys, and only 8 out of 10 of the M8s are being used. The reason I have these doubled up on the controller is to signify the 2 ends, one end here and the other end at the HyPer9 motors. And then we got B plus and B minus. Those are heading over to a 48-volt contactor, the main contactor. I had a Tyco EV200, but that was recalled, so they had me send it back. And the GV200 is what I have remaining, but I believe that's the 12-volt contactor here, which is part of the DC to DC converter circuit. So I gotta figure out who this is. Sent an email out, so we'll get some answers. The shunt has a lot of attachments to it. We have a couple other contactors that are floating about here. I'm gonna have to find them, but I say about because they are from Canadian EV, and they're the contactors for the air conditioning compressor, and one for each of the heater cores. And they're all gonna be running smaller wire, something like this. It looks like we got a 14 gauge here, a 16 gauge on that one, etc., etc. The kill switch here, our big boy by Rincon, that's got another 2 connectors on it. This top lid for our contactor box is representing the under the hood battery box, our front battery box. 3 modules, which is right here. This failer, $1,000 of aluminum, that's what it'll get you. And really well made, actually. The front battery box will have a high voltage sticker on it. EV West also has these, they call them phony stickers or something like that. The fake seal of the state of EV West. That's really great. I don't think I'll be putting these on the car, but I'm definitely going to include them when the car is brought back to the client. So I'm really looking forward to wiring. Like, this is super exciting to me, but I digest. Let's move on back to the front battery box. This heavy duty, heavy voltage fuse. This will hold up to 600 amps. Amazing. We got a spare one here. Always keep a spare fuse in the glove box if old Volvos have taught you anything. And if this pops, you really have a short. Like, you really, something went wrong if one of those big cables is shorted somewhere. Yikes. So the battery box will have, the front one has the kill switch. The kill switch lives right here on the side, as we've discussed in the previous videos. And our gland nuts, these failures are going to be attached to the parts of the box that I drill to attach the cables going in and out. It could be on the side, could be on the bottom. We'll see. And the final position of our controller is also TBD because the battery box needs to go back into the engine bay and the HyPer9, and then I can see exactly how much room I have. I have a feeling it's going to live up close, or it's got to live like up into the side, but I just want it to be attractive. Part of the controller is going to be the cooling system. We have our Deraillé cooler up in the front, which is a miniature radiator. Once our condenser gets installed and that feller is mounted up nicely to the front, we will install the rest of the cooling system, which is going to be a catch can or a reservoir can. This lives at a pretty high point, so I might grab a drill and some Josh Groban bits and raise it up a little bit. And then I'll have this pump here also somewhere nicely attached, which will circulate the fluid. This is a contact-free pump. I went through and pieced together the kit that an EV company sold and saved like $400 by getting the components individually, and this was the only one that I couldn't find from their setup, and I looked at like hundreds of reservoir canisters to find this guy and then get the right bits for it. But it was like, I saved a couple $100, but spent a few extra hours shopping around just to make sure that I could get the same pump, the same cooler, and the same reservoir canister. All right, so that's all fine and good. This beautiful chrome dome here, it's not a Cylon, but if it had a red light in it, I think it could pass for one. In fact, installing a red light in here could be kind of cool, huh? But it's just a vacuum pump. This is the pump brought to you by Lead Brakes, and Lead has a rotary style pump. It's not the piston style that like does that. This is going to be just a whooshing sound. It's really quiet. I'll put the clip in from their video, which shows the difference in two pumps here.
As you can see, it vibrated our whole display, and it took a little while to get up to 22 inches of vacuum. As you can see, the Bandit series pump is much quieter. There's no vibration. It gets up to vacuum much faster, and it gets all the way up to 25 inches of vacuum.
That was easy. I didn't have to do the test myself. This is our vacuum line that comes supplied with it. Lots of length, beautifully braided like a little challah bread. And then we'll add some butter on the ends, put it into the pump, and it's good to go. Let's talk the rest of the vacuum system, and that is, of course, the reservoir tank. EV West has this reservoir tank here. It's small, but it seems to do the job for getting your power brakes to work. And the reason why we're not going to use this, we're actually going to go back to the original Volvo metal canister, because this lives under the glove box. It has its bracketry ready, which is a plus. But more importantly, it's the larger capacity needed to run all of our HVAC systems, because the entire HVAC system is done through vacuum operation. Now, the other stuff in the trunk will include the charger. Charger needs to stay nice and breathable, so whatever we do with it, I want it to be in a place that's happy, healthy, and not too hot on a summer day where you could leave it charged, leave it plugged in, and it's not going to overheat. But I think it has its protections inside of the software, which I will have to find out more about later, to stop charging if it overheats. This failure also is using, looks like 10 gauge, maybe even 8 gauge wire. So we'll have those attached to the connector. I think it heads over to the shunt, which then distributes it to the system as a whole. Our favorite guy right here, the J1772 with the soft open. I just love how they've metered the opening rate of that spring. Oh, that is so good. There's the high voltage fuse, the 2 gland nuts. That is the battery box. The battery box will also contain the BMS satellite. And I put a note here, make sure to check with the tester before plugging in. There's already high voltage in the wires that I've plugged the connectors into the battery, so I want to make sure that all of our wiring is done correctly before this goes in. And the charger will communicate directly with the AVC2. Under the dash, the brain box for the Canadian EV AC compressor. I'll probably label these, Lument nicely. We have our tachometer interface. This is from EV West. It's CAN bus analog tachometer driver. This is a really nice thing to probably get the Volvo tach to work with the RPM of the electric motor. It'd be so fun to watch that thing spin up. The only trouble is if you get it past, you know, the HyPer9 will spin 9,000 RPM, 8,000. We don't want to overbear the needle on the tachometer, so I wonder if there's going to be an issue regarding that. But I also wonder if it's going to even spin that fast when you get it into 4th gear, because it's going to be 2nd gear in the city, 4th in the highway. The 5-to-1 TBS Electronics voltage prescaler is going to take the high voltage 140 volts and take it down to something that won't fry the TBS Expert Pro battery monitor gauge. We're going to be sure to program this inside of the settings on the Expert Pro gauge. And that should be our one display, our one non-original Volvo display in this car. One of the tricky parts of the install and what I've been dealing with the last couple of days is just, where does everything go? You know, this is the contactor box, and it's underneath here where the passenger footwell is. I like that spot for it. There's really not much there except for, well, this air tank. That was the old vacuum supply for the climate controls. You know, to make the most of our available space, I think what I'm trying to say is this guy could go somewhere else. And one of the other considerations is our new vacuum pump, the rotary style by Lead Brakes. It's awesome. It's going to be very efficient, but it's going to be all the way in the front. So that would require a hose to run into the cabin just to tee off to a tiny hose, which will then go off to the climate controls and then send another big hose through the firewall. So a second hose through the firewall into the brake booster. That's too many hoses, so we could simplify our hoses by putting this guy up in the front underneath the battery box, because I have plenty of room there, and I don't want to put electronic components under the battery box because that's where a lot of rainwater, snow, dust, things get through. And I feel like a tank could handle it a lot better than a controller or a charger or a DC to DC converter. So let's try that. That means that we have all the space here under the dash, if we account for the vents, to put something like a contactor box. I like this. This is a very good use of space. The question now is the wiper motor. How much clearance do we need to make for that arm? Look at it right there, because it's pretty close and it rotates. So if I drop it down a little bit on that side, on both sides actually, do we get in the way of our feet? Well, we don't want to have to get in the way of our feet too much, because it might make your passenger uncomfortable to think that their toes are touching a 144 volt contactor box. They don't need to know really, but we can also paint it black and it'll be less conspicuous. But really the driver's feet are what matter the most. So I'm thinking that might be our best option. So whatever you do, you want to consider like how serviceable is this section, because if we put it somewhere, will it have to move out of the way for some other reason? And if that happens, do you have to remove everything, or can you just remove a couple of bolts that hold it down? So the stuff engineers have to think about too when they're working with the designers. The design team's like, we like the shape of this fender, and the engineers are like, cool, how are we gonna fit all of our suspension and then like keep the size wheels that you want as well, because we really got to make room for every component. And we've seen time and again how the frustration from mechanics and technicians are surrounding the decisions made by engineers and designers. There's a grommet up top. That was for the vacuum hose for this failure. And then there's the two grommet holes there. Those were for those are going to still be used for the air conditioning lines. And then this big guy here at the bottom with the two bolt holes on the side, those were for the linkage for the throttle pedal, which means I have a big grommet to use for some of that heavy duty cabling. I think 2 of our 2-aught wires could fit through that if we needed to. So I think we should do it. I think we should put the contactor box right here and call it a day. Turns out they can ship batteries, especially Optimus, because they're sealed lead acid. They'll do ground transport, they won't do air. But let's see how this fits inside of the car. 5 hours later, we have a battery box. We've got sides brackets for the DC converter, bada boom, and a huge mess. I'm covered in aluminum shavings. I have been enjoying this process. Tomorrow we'll mount it up inside the car and peel the rest of the plastic off. But essentially the battery, I'll show you what it looks like inside. Yeah, it seems really weird to have the posts going through the metal like this, but I'll put some rubber grommeting around it so we can keep those really insulated. But there's also that ledge. That's nice. And cool aluminum underneath here. So this will bolt to the bottom of the battery tray. And then we'll have some screws on the safe parts of the corners. There attaches the DC to DC converter. We'll put the holes here and then just trim the bottom tabs a little bit there. Okay, we took a aluminum battery box kit, and we bent it using my new metal brake. It's awesome. It's really good to have a brake, which means I gotta take one too. It's 1 a.m. See you tomorrow.
君が空から降りてきた時ドキドキしたんだ。きっと素敵なことが始まったんだって。
I'll wait to take the plastic wrap off until more or less everything is finished, but we've got a pretty secure battery box. 3 bolts holding it down, and 2 here on the side. Those 2 also control the removal of the lid. The lid is also, it sounds like it's getting complicated. The lid also is held on by the DC to DC converter being bolted down to the bottom bracket, and then the top bracket is just part of the lid. And it's pretty stable. Ain't going nowhere. Well, the handle is just there for fun because it actually fit nicely with the channel that we left in the middle. You got your specs on your battery there. 450 cold cranking amps, 38 amp hours. Reserve capacity, 66 minutes. Speaking of tight clearances, look at that. Ooh, nice. Barely, huh? So we have a ground strap there. I left the studs open, and we're gonna do a double nut on this side, so that we have our lock nuts for the wall of the battery box, but then we can add clamps to these so we can kind of control the wiring and make sure all of the cables that run around the battery box are nicely clamped. We'll use Adel clamps. Should be very pretty by the end of it. Okay, I think that's it for battery box stuff. We can move on to other things. This is the harness that I have to now clean and connect to the front for the headlights. The rest of the stuff's looking pretty nice in here. All right. With the magic of editing. Much cleaner. Overspray notwithstanding. Let's install it.
A lot of like these relays and other stuff will be in there as well.
Like I got the Canadian EV heaters, so I'm supposed to add some more fuses for those, but then I emailed them and they're like, yeah, you want this specific fuse that it like doesn't blow immediately, kind of like.
We use these for all of our heaters.
That's good to know, dude. Yeah. And like this should just be the low voltage stuff. Like don't use these fuses for hot.
Yeah. So basically like your factory 12 volt in your car, you already have a fuse box or a fuse panel. So you use that.
Pre-charge from there, go to lug.
Yeah, pre-charge to lug. And then you'll see, if you look at the red line going to the coil of that relay, right in the middle there's that tap, and it drops down and it actually taps into power, so they actually take the voltage times the amps, and then that gives them real-time kilowatt rating, which is pretty cool.
That's so great. Okay, so this is 96 or 144 volt setup?
This is 96.
Okay.
Yeah, it's just 4 modules. So here's the layout. You can actually see the 4 modules. 1, 2, 3, 4, right? Nice. And these are all the individual cell voltages.
My batteries have been on the shelf for like 1.5 years now. I'm like,
they can go 10 years, dude.
Okay, that's great.
As long as nothing's hooked up to them.
Yeah.
So
how delicate are they, too?
If you have the factory board that's Tesla, take that off.
No, you guys already did the boards on them. I paid that extra.
That can sit for like 15 years. Yeah.
I noticed there's a few spots where either you did solder repair or somebody else did solder repair for the individual cells, or there was like probably one that might have broken before it was sold. Because you'll see like it's moved a little bit to the side, and then there's like a paint mark on that area.
No, that's Tesla.
Okay.
Yeah, no, Tesla does. So on your current collector, you have like a Sharpie mark.
Yeah.
That's Tesla.
Okay, cool.
Yeah, check this out. It's fascinating. No, you see that?
Because they're very tiny. I'm like, how delicate are those? Because there's a plastic cover on top, and if you...
talking, this is a California company, so they're probably a little casual to some degree. But my buddy that worked at Tesla, we saw some stuff with like this.
Yeah.
He's like, he was like, that's rework. That's a remanufactured motor, because they did it originally orange and then they did the rework green. And he also told me they'll mill this. This normally is a casting, and they'll mill that to stamp the new part. So this has a new serial number now that it's been rebuilt. And so they do that a lot. Look, this one has it too.
Nice.
A ton of their stuff gets reworked. But
so many batteries.
fairly common. You'll see, Sharpie marks. Like somebody said, hey, double check these, and then they double checked them and did that. But then you'll see other ones with just, like you said, like little tick marks.
Yeah, and it's just moved a little bit.
Like here, you got some marks, and then there's some stuff. And if we looked closer, you'd see maybe some rework done on that. That's got Sharpie marks, see? You probably have something like that.
I thought that was you guys going in and just checking everything.
And it's not. And some people think it's on the case, but it's not. It's on the current collector. So this was done. We don't take the cases off.
Because, boy, they were tight getting them into the box, especially with the black plastic. So, like, I'm so nervous that one of these little guys might break if they, get torqued the wrong way.
Yeah, that's a good, valid concern. We usually use, like, really thin straps and set them into the box with a thin strap and then pull the strap out.
I was having so much trouble with those black plastic.
These are depopulated ones. They make them a little lighter. They pull some cells out. They have a little bit less capacity.
Nice.
So,
that's quite a collection in here. Wow.
So
business is going well?
This is a tiny bit of most of it's in the other one next door.
Every time I'm here, I'm like, how big is this place really? Because it seems like I've only scratched the surface.
And if you look over, like this is kind of a fun little corner to look into because it's just been motors as far as you can see.
That's amazing.
Really cool cars.
That's so cool. Wow, I had no idea it was this big.
Yeah. It takes a lot of room for started working over at EVLC. Yeah, I think so.
This is crash card number 2 we were just looking at.
You know one that should have been on our list that we forgot, and surprised we forgot? Grandma.
LTC select. Nice. Nice. Hit that for region, forward, reverse. I like the way they set this one up. The ignition key goes to a distribution box 12 volt switched and another one for 12 volt constant. Cool. Those guys go to this guy, which is our alternator, DC-DC converter basically. And then that second wire there runs down to another breaker and the battery. Cool. Protection. Top one is 80 amp ignition protector. DC-DC enabled charger.
You have the original BMS, which means you have a BMS master and a BMS slave.
Yeah.
Okay. Which works really well. And if you have the older chargers, it worked really well because the older chargers were pretty dumb. You supplied power, they turned on, they charged.
Yeah.
If there was a fault with the BMS, it opened up the charge loop, charger stopped. Okay, cool. Chargers evolved. Chargers developed a CAN base, controlled area network. At that point, we needed something that says, okay, when you plug this in, it sends the CAN message to tell the charger to turn on.
Yeah.
That was the EVCC. Okay, cool. Now we had the EVCC and a BMS. And the BMS had the master and the slave.
Yeah.
It's just neat, but we got modules all over the place. So if we take the EVCC and we connect it to the BMS master, we create the MCU.
2 in 1. Bada boom.
And so that means that I have red, black, green, and white. That means I have red and black. Well, in my world, red and black is DC, that's power and ground.
Okay, yeah.
And that means I've got green and white left over. So that became my CAN high and CAN low. I went, okay, well, white is the color of clouds, and clouds are high, and green is the color of grass, and grass is low.
Ooh, I love that.
So white is high and green is low.
That's great.
There you go.
I'm figuring out the contactor box. We've got it mounted in the car. Now it's time to add our gland nuts. These failures here, 1-inch hole. I got an updated schematic here from EV West, which very importantly changes our pre-charge high voltage feed here versus having it go right there and frying our controller, because this is not the 144. The contactor box here, we've got 4 major ins and outs and then a 5th, which will be like the smaller wires. The 4 big ones are gonna get crimped through this guy, and it's gonna be a tight fit through here, but we're finally at the point where we're starting to attach our EV components and then like route the heavy duty cables. So we'll put our 4 holes here, and we have all of our fuses labeled. high voltage relay, charger, DC-DC converter, heater low and high, and the air conditioning compressor. A couple of big tools today. This is a very useful one. This is a heavy duty cutter because this ain't gonna do it for the 2-watt cable, but our snap-on dikes are just top choice. Diagonal cutters, calm down. And we've got our terminal ends here. These are the M8 on the ends, very hefty, so they need a big boy to go ahead and crimp those ends. And when the ends are crimped, they look very nice, hexagonal. A little bit of trimming that happens because it smushes the ends, and then I take a file and just smooth down the edges. But this is our crimper here, heavy duty, the YQK120. It's like $100, I think, 60 bucks at EV West. There's some versions of this for like 35 bucks on Amazon, but it's just a nice big hydraulic press essentially, and a lot of adapters in there. We'll go down to like as small as a 6 gauge, as high as like 4 or 8-watt, 8-aught. I don't know. It's a big. It can get pretty big with these dies in here. But it's a hefty tool. It's very nice. Right now, these are the pieces that attach the battery from one battery to the next. These attachment points, and then a couple of those, the fuse, and then the box itself should be more or less complete. So we saw that flexible conduit is like $1.90 a foot versus the rigid stuff. That was like 2 years ago when I was at Lowe's. So I picked up 25 feet of this. It's 3/4 inch, which fits the heavy duty cabling pretty nicely. 25 feet, and it's gonna go under the car, and I can make all the bends I need without having to take the heat gun and the pipe bender out. So I think the time saved is worth the extra cost for this. And then I'll show you under the car when it's all attached. We've got 2 attachments to make. One of them is rear battery box negative, and that's gonna go all the way to the shunt in the contactor box. The second contact to make is going to go here, where this is what we're installing now, and that's going to be front box to rear box positive. All right, so these two are going to run side by side. We got some clampies and screws, hardware, all this stuff. We'll see what we can make it do. I'll work out the trimmings here later, but let's follow these down under the undercarriage. Lots of little connections happening. Here's the second line. This is the positive from the rear box. It's going to go straight to the high voltage fuse. That fuse is going to live inside of this box. I've already got the connector there for the BMS 2-wire pinout there, and then there's the main kill switch, which is now in the off position. And you can see that, you know, there's that much space between our condenser. Hopefully we're gonna have a fan that's really, really slim and mostly out of the way, because you can see it's getting pretty tight. But this box is not in its final position because, of course, the brackets are still being manufactured over there by Soren. And then I'm gonna be crimping this failer now and make sure to label it appropriately, that it's red because it's the positive going from that. And then the second attachment here is going to be for the fuse, and from there it goes to the battery pack, other side of it, and then this cable here will go into the contactor, I think the main contactor. Let's see. Yeah, there's our main switch down into our main contactor, and the contactor then has the final connection to the B+. Actually, no, yes. Actually, yes. Important thing to remember before crimping is this guy needs to be attached to the line, the entirety of it, because it won't fit through afterwards. So you want to have all the holes made and then slip on your gland nut, and then it will go in to the box and thread in from the other side. Time for a little check-in now that the sun's out, briefly, and we'll start here with the box. We've got most of this assembled. It's all gonna have to come out because this is gonna get powder coated, I think black. And we've got the two wires, the main ones. This one's going to the kill switch from the rear set, and this one's going to the fuse from the rear set. One of them, yeah, the kill switch one goes to the controller. We have our AC lines finished up and the AC compressor is installed. Here it is. I'm gonna wait to do the final bolting up of these guys until I have the vacuum pump ready, because once you open this up, any sort of atmospheric condensation or just humidity in the air, it's gonna start to affect the compressor. So we're gonna wanna pull vacuum immediately. So we'll do all that in one day, and hopefully, fingers crossing, the rest of my connections are pretty solid and tight. Vacuum canister is sitting right on top of where the brackets will be for the battery box. That's kind of a bummer that I'm waiting on that. I'm sort of anticipating my clearances, but I put it a little bit higher than I think it's gonna sit. And then the hose for the vacuum canister exits right there in the front. You can see the nipple on the bottom plugged up. So our two AC lines are there. I had to put a little heat shrink on this AC line because it started to get kink in it. I'm hoping with the pressure the kinks are less prevalent, but it doesn't like bends because it's a reduced barrier number 10 hose, because this guy is a reduced barrier number 10 fitting. Boo! Or that one's the number 8. Here's the number 10. Boo! Wiring is cleaned up. It's looking pretty nice. I'm gonna have to add a little like a circuit breaker, which will then connect our ignition switch to a lot of our 12 volt systems, and probably replace this guy. This is the Volvo one. It's fine, but I just don't like that it doesn't have like its own fuses there. But speaking of the fluid pump, it's here inside of the bucket. I need to check the flow direction, and it doesn't want to be run dry. So I'm gonna see which way the water's running when it's got the power probe hooked up to it. And then once we figure out direction, it wants to be mounted low in the system. I had initially put it up here at the top of the radiator, so it wants to be nice and low. So from the bottom of the radiator, the fluid's gonna go right into the controller, and the controller is gonna be probably underneath some of this stuff, maybe. It should be pretty low. So I guess having that pump towards the bottom is the most efficient. And then we can use the space up here for the overflow tank, because the overflow tank is shiny and we wanna see it. But why don't we go inside and we'll look at the contactor box. That's where a lot of days of work have happened. It's getting tight in here. I don't like this very much. I'm not thrilled about how the cable has to make a twist. I could have probably put the main contactor further this way and used like, I don't know. It's these bends that kind of throw me off, because this cable is so thick that it doesn't really like to make bends. The twist is okay because the top lid of the box will sit higher than any of these components. So I'm not worried about clearance in the box. I just don't like the twists. Like this top hole here, it's gonna have to make a twist or a 90 degree. I'm hoping that's enough. I'm gonna need a special grommet, because these guys here, as nice as the gland nuts are, and they're really there to keep the cable solid, this front end cross threads very easily. I can't get it very tight. It's like you get one chance at tightening it, and if you strip it or if you over tighten it just a little bit, it rounds all the threads off and then it starts skipping on you eternally. So they're kind of just stuck like that, which is a bummer, but I'm gonna try to be careful with the others. The AC lines happen to fit quite nicely. I was really happy with the way that worked, and we have a few lines of cable going around these two AC ports. I'll go ahead and tighten this up, and I think that's it for AC. And then at the end, when I start doing the vacuum, after all my vacuum is pulled, I can go through with the foam tape and wrap up all the rest of this bits and bobs and make sure that it's nice and insulated, because we want our thermostatic expansion valve pipes to be insulated. The valve itself, I think, should stay out and ambient, but it's going to be like up to here. So inside of the box, we have 3 contactors. This is, each one's labeled. We have our heater low, heater high, and our AC compressor. And then those run the high voltage cabling, which should be orange, but it's very expensive to get orange cabling in this size. So I think these are 14 gauge. I ended up just getting a red, and we can wrap them with some orange loom if it's an issue, but it's all high voltage stuff, baby. We got orange zip ties at least, so we can celebrate some labeling. Really happy with my printer, my little handheld printer, because I can label things like heater core 1 and 2. And then double checking, triple checking all of my connections, like knowing that this goes to the controller positive B+, this goes to controller negative B-. I want to put a label on this so that I know that this is the guy that comes from the rear box negative. There are some clues for what's positive and negative, black and red, of course, but you know, sometimes it gets very confusing and there's room for mistakes, and mistakes can be very bad when it comes to high voltage. Our fuses are in place. I like the system I've got over here. I put a little bit of a service loop and everything just in case, because I learned that from residential wiring. You always want to have a little service loop, which is what all this is right here, in case you got to cut something later and or move it. So we're getting pretty close to the end of our heavy duty cabling. I might have to steal some from Ivy to get the rest of the lengths, but that's okay. We'll just buy some more. I think they sell it by the foot. It's like $3 a foot. And I'm gonna get it from EV West, because inside of our heavy duty cabling, you know, we've got 2 layers of insulation, really nice. The way it almost looks like it's rifled, like the barrel of a gun. Each of those is an individual cluster of strands, and they are also braided. So we know that electrons flow on the outside of wiring. That's why the more strands you have of cabling, the more surface area for the electrons to run. And it's a really cool setup. So these are good wires. I wouldn't use something from like the Home Depot or Lowe's, which does come in big sizes, but I would not put that inside of an electric vehicle. I'm not happy with the radio fitment because I don't have details of how it was before, but there are clearance issues with the face of the radio and the face of the entire panel. You can see that there's like some overlapping, and there's barely enough room here for a cassette to go, but I don't like that. It should be shaped exactly, not like this. Otherwise the radio's sticking out and then it gets in the way of the ashtray. So I don't know. Volvo was weird with this kind of stuff. I think it's a premium option to have the stereo and the 4-speaker system. So now that I've gotten comfy in here with all my pillows, I'm just gonna take a moment, collect my thoughts, and keep going on the list that I've set up. A lot of little turns, twists, bits and bobs to connect. It's like so many hours spent on each component because I want the wiring to look good, clean. I want it to be serviceable, and then you're plotting ahead as well. Like, I need to know that I have access to the hardware for everything and that nothing overlaps it inappropriately, so that I can't get something out without having to make a big mess of it. For example, our bracket for the vacuum pump in the front firewall, I needed it to be far enough to the side so that it clears the contactor box. And you can see one of the bolts there, right there, just on the side of the wall. Like, that's as close as I could get it anymore, and it's going to start kinking the lines for the air conditioning. So there's a lot of little things like that, and it's just been a bear, but that's what takes up so many of the hours. That and the details and like keeping things serviceable. We don't want anything falling apart over the next couple of years, so it's important that we do it slow and correctly, because we got to have that quality going. It's just unfortunate how much time it takes, and I worry that after doing car number 1, car number 2 there, I'm not even going to want to start it. I'm going to be burned out. Help! But maybe that feeling of like I accomplished it and number 2 should be much faster, that feeling might help quite a bit. One more thing I want to show you guys. And the rear, oh my goodness. So we got our two heavy duty cables. We got the one for the fuse, one for the positive end of the batteries. This whole back of the battery box is covered with a foam sheet for sound insulation and a little bit of temperature insulation too. I want to make sure our batteries are happy all year round when it's in storage, but there's just like, I don't want to ever have to go back inside of that battery box, so I'm only going to put it in its place once, and that's when the whole car is finished. I got to revisit some of the order of operations of getting the expansion tank set up with the coolant pump and what all the different components are going to be. A couple of notes. We want, of course, this to be the highest because it needs to bleed the air through the system, but the instructions are having us put the pump at the lowest point, kind of like how in a water dam or a river dam, there's the turbines are at the bottom of the dam. So that's going to be placing the pump at the lowest point. The pump inlet should be the lowest pressure, and we want the most water above the pump, but then the outlet of the pump needs to be, it will be the highest pressure, and that needs to be sent immediately to the place that creates the most heat. So that means our pump is going to be the last thing before the controller. And then from the controller, it's going to go back to the radiator inlet. It'll then cool itself through the radiator inlet, go down to the outlet, and from the outlet, it will run into the expansion tank. The expansion tank at our highest point will have the lowest temperature coolant in the system. It will also have the lowest pressure, and then it wants to get it wants to be as close as possible to the low pressure side of the impeller, which would be our pump as well. So essentially, expansion tank to pump, pump to controller, controller to radiator, radiator to expansion tank. That's it. And over yonder, it looks like, if this diagram is anything to... that's one problem I'm noticing, is asking for 12 gauge wire, and I happen to have used 14 on everything. That's because the heater circuits wanted 14, so I didn't know that the AC, I didn't check that the AC was 12. I'm gonna go ahead and just undo that one, and oops, we live and learn. It's time to mount the controller. I'm working on another one of these foam templates, and here's our controller base. It's gonna sit just like that, pretty close to the brake lines, but we want to keep everything serviceable, so like hoping to clear the whatchamacallit, steering adjustment, but not too far over this way, so kind of want it to be as low as possible. It's 2 a.m. I forgot which way my orientation went for this bracket, but you can get a pretty decent look at it now. Goes right over the steering box, ample clearance. And then the red is where I'll cut it here. Cables will swoop down along this side, kind of hang out with these two, probably go forward of the battery box and into the side of the motor. So should be a nice travel for those. These two here have to end up inside the firewall and into the contactor box, and that's probably going to have them swoop down and then cross underneath here, and I might make access points there. If not, I can have them swoop down and put access points here, but we're already getting kind of tight on firewall space over here, so I'll have to figure something out with that. I think the other side is really my best bet. The harness, is it cleaner to have it on the top and put the harness over yonder, or have it in the front and then it just dips down and I could hide it? I forget, but it's time to go to sleep. As the accessories are coming together, it's time to test our circuits, especially now that I'm putting this fuse panel here. And this is the 12-volt switched stuff, so we're going to be running right to the battery here, power probe. This is the vacuum pump. Hose hooked up to the tank, just to check. Very quiet pump. It should turn off automatically once it gets to a low enough vacuum. Cool. It's quiet too, because it's a rotary style pump. That's a lot of vacuum on this little guy. But if the vibration is too heavy from there being on the firewall, there's these rubber isolators that came with the kit, so I can swap those in place. But yeah, it's getting kind of messy, little steps here and there, but you know how it goes. 3 amp, 15 amp. This is the original fuse that was in the kit, 15 amp. There's no lettering. I mean, there's lettering on it, but there's no white lettering. And one of my boxes of fuses had this little guy, which is 15 amp, and it matched the color of the original fuse, but it's the wrong font. It's a little too small and skinny, and so I went for a third option. And does it matter? Why am I this way? Why do I care so much about like, I can't mismatch hardware. If there's 4 screws holding something that nobody will ever take apart, knowing that the 4th screw is like the wrong shape is really gonna bug me. So I end up getting hung up on things like this. A bit of an angle, you know, as they're bolted down like this, it, you know, might be flat where my fingers are bolted down to it, but then at the end, it's gonna be up a little bit. So it makes everything tall like that. Thankfully, the front side of the contactor box is just as deep as the bottom side, so that should be fine. And yeah, it's a lot of guesswork, but we're making it happen. We're really getting some hours put in now. And as I approach the harness wiring for this beauty, this is the 35 pin, but like 18, 19 wires that it's going to go from the controller inside of here and connect to everything. Just want to catch you up a little bit on my progress. We've got a few things that have been done in the last few days. Trying to get hours in every day. Trying. We have our circuit breakers wired up. They are connected to the battery, but we have a couple of wires. There's a lot happening because this is the bigger stuff that just gets sent to our distribution block underneath the radiator and all this stuff. And it's going to connect here. A lot of little bits and pieces. We have our distribution block there to replace the old one, which was kind of falling apart and really insufficient. This one's pretty hefty, 3 big terminals, and then I think 4 smaller connections if we want to add things later. This always sees battery positive. We have a fuse panel. We talked on that a little bit, and this has lights so that I can see if the fuses pop. This is 12 volt switched, so anything that's needing a 12 volt switch signal, like our high voltage pre-charge relay and other accessories, we've added the fans, the water pump. Speaking of, oh, that entire assembly there is fused. It's relayed through a Bosch relay. I was going to use like a generic one I had here off the shelf, but I want to go with a brand name, something we can trust, because we don't want a generic relay failing and then having our water pump and cooling fans go out. Those are kind of important. That will be, that's a 40 amp relay, so I want to make sure that all my accessories are limited to 40 amps. The fan's like 5.3, the water pump's 2. This guy here says 10. We'll see. Vacuum pump is a vacuum pump, so. If I followed this, I would essentially be putting in from the high voltage key switch, high voltage 144 volts, boom, and that would fry the inverter because our inverter is isolated. So that's the non-isolated wiring diagram. That's something I learned later. The isolated one, that same high voltage actually ends up going over to the B+ pre-charge. So the pre-charge, I don't know what the inner workings are of this, but based on your number, you want to make sure you have exactly determined. And the easy visual is that little lug terminal there. Okay, so after that, some of the safety precautions, we have wiring, we have a diagram for the isolated logic, and then there's instructions here on how to wire all the pins. I'm going to order some crimp connectors for these amp terminals. And then we have our main contactor. It's externally economized. I think that's the word. And then the high voltage relay, this little guy here. No terminals are written on it, so I went and labeled them. 4, 3, 2, 1. 1 and 2 here are the 12 volt signals that are from the ignition key, and I think it's like 5 amp. It says on here. High voltage in and high voltage out. So this is kind of cool because it's a relay that's triggered through the 12 volt system, but it takes a high voltage signal and relays that. So that's fun. It's one of those little, it's a very special little relay here. If you're going to redo this box, which I am going to do for car number 2, put your contactor and your shunt further towards center or further away from where these are, because the big cables, they don't like to bend very much, you know. And I worry if I bend it too much at the terminal ends here, I could risk pulling some of the cables out through the lug stud, you know, and the crimp that I did there. So I don't know how much of a concern that is, but we're almost through adding connections. The pre-scaler is next. So AC stuff is all finished. The electric power steering, look at that. The adjuster knob is right here. We had a hole right there from, I think somebody added a fader for the front and rear speakers. It was non-original, so I will remove that. And we have our easy power steering adjustment there. So right now it's set to the middle. Time to attach the chill plate to the controller. It's 400 grit sandpaper, get some of the imperfections out. As I was going through it, you can see this very clear line in the casting. I don't know what's going on. There's two halves of this, and I don't want to cut down any more than I need to, but just enough to get some of the deeper scratches out. And then we'll bolt it up. We'll use the silicone here. Got RTV black that comes with our kit. And then some of these chill plates do have a threaded portion for a temperature sensor. I don't have that luxury here, so I'm only dealing with the inlet and outlet ports, but they seem to be nice and snug as a bug in a rug. And EV West made a comment about how they use as much surface area of aluminum as water, something like that, which is the maximum cooling. So whatever ports they've designed here is just awesome by their calculations. But I'm no math surgeon. I'm just the guy here attaching the silicone, and then we'll put it back in later, because those bolt holes that run through the controller are going to run through this aluminum plate here into our bracket, and then we can start attaching all of our cabling, the harness, and then figuring out the final selection of these guys here. I'm going to mount them right up to the front of our controller brace, or I'm sorry, our motor mount. And yeah, just gonna tidy things up as it comes together, slowly and surely. Battery brackets are here, and wow, Soren's amazing. Look at this. He's actually added a really cool feature, and that's these bolts on the side that allow me to cinch.